In previous session, we discussed about analytical method of dimensional synthesis using Fodase equation. We know that in this case, for three input angles, we have three corresponding output angles, and we are going to synthesize a mechanism using Fodase equation. Means, for designing a planar four-bar linkage, such that three given positions of crank defined by theta 1, theta 2, theta 3 and corresponding three positions of follower, that is phi 1, phi 2, phi 3 are given. Then for dimensional synthesis, we can use Fodase equation for these three positions, and you can write it as, let's say it is equation number A, this one is B, and equation number C. Then if you solve this, we get K1, K2, K3, and further by using formulas of K1, K2, K3, we can find out dimensions of link lengths. That method already we seen. But in this method, that is in method of kinematic coefficients, instead of solving these three equations directly with the help of calculator, one new procedure is derived, already known, that we'll see how to solve these numericals, how to solve these equations by using kinematic coefficients. So first step after obtaining these three equations is we can write, as we know these three equations, we can write equation A minus equation B. So this, if I do this equation A minus B, it gives, so you can see here, see what actually we are trying to do. We are not using calculator to solve this equation in this method, that is in kinematic coefficient method that we are studying now. In this method, we will not solve these three numericals, three equations by using calculator, but instead of this, we will try to find out kinematic coefficients. What this? To obtain this kinematic coefficient, first step we will do is, we will take A minus B. So equation A minus B. So what it will gives you, you can check now, equation A minus B. So K1 cos phi 1 minus K1 cos phi 2 and so on. This equation A minus B. What it gives me, if you see here, I can take K1 common. So it is K1 of this cos of phi 1 minus cos of phi 2 minus K2 into cos of theta 1 minus cos of theta 2, and here it is equal to cos theta 1 minus phi 1 minus cos of theta 2 minus phi 2. So by A minus B gives us this equation. Now we will also find out what is A minus C. So first step, equation A minus B, and then next step, after getting A minus B, we can write A minus C, that is equation A minus equation C. So we know these two equations, you can just see this A minus C. So it is K1 cos phi 1 minus this equation, that is this equation, minus this K1 cos phi 3 minus K2 cos theta 3 plus K3 and so on. So just similarly, instead of here, what I get, K1 again common, instead of phi 2 it will be phi 3. So K1 cos of phi 1 minus cos of phi 3 minus K2 as it is into cos of theta 1 as it is equation 1, theta 1 stands for 1, minus equation 3 means cos of theta 3 is equal to this A minus C, right hand side, cos theta 1 minus phi 1 minus this term. So it is equal to cos of theta 1 minus phi 1 minus cos of course it is theta 3 minus phi 3. So we get these two equations. If you see these equations, if I replace these coefficients of K1, coefficients of K2 and this term by some constants, they are nothing but a kinematic coefficients. So these two equations that we obtain by using A minus B and A minus C, I can write it as K1 into W1, where W is kinematic coefficient. So what my first coefficient is, let's say I call this one as This cos of phi 1 minus phi 2 I call W1. Cos of theta 1 minus theta 2 I called W2. This one is W3, that is coefficient 3, coefficient 4, 5 and 6. These are called as a kinematic coefficients. Okay. So I am writing now this above equation as, or you can write, say, let's say write constants here. So now putting W1 is equal to, we will not call omega 1, we call W1 is equal to, what is W1 here? We can call this equation, first this equation, W1 is equal to cos of phi 1 minus cos of phi 2. Similarly, W2 is equal to cos of theta 1 minus cos of theta 2. W3 I am writing here, or you can write here also, W3 is equal to this cos of theta 1 minus phi 1 minus cos of theta 2 minus phi 2. This is W1, W2, W3. Similarly, we can write from this second equation as, so I am writing here, this one is 4. So W4 is equal to, means coefficient of K1 in the first equation is W1, coefficient of K2 is W2, this one is W3. In second equation, coefficient of K1 is W4, so it is cos of phi 1 minus cos of phi 3, W5 is this cos of theta 1 minus cos of theta 3, and as there is no space I am writing here, it is W6 is right hand side of equation this, that is second equation, cos of theta 1 minus phi 1 as it is from first equation minus cos of theta 3 minus phi 3. So these 6 coefficients you obtain, and these coefficients are called as a kinematic coefficients. So if you use this coefficient to solve Fodase equation, then that method is called as a method of kinematic coefficients. So I hope you understand up to this what we did here. Just we written Fodase equation for 3 positions A, B, C, and then by equation A minus B and equation A minus C you obtain 2 equations. Now writing coefficients of K1, K2 in terms of W1 to W6, we get these 6 coefficients. So we have this 6 coefficient W1 to W6. I explain how we obtain that. So now this equation A minus B and equation A minus C that we obtain, that we can written in terms of these coefficients. So that equation can be written as now. So let's say here this K1 into this constant we know it is W1. So K1 W1 minus this K2 into W2. Instead of that terms we write constants is equal to, this one is W3, and second equation it has K1, yes it is K1 W4 minus K2 W5 is equal to W6. Okay, so let's say call this equation as I called above equation ABC, so call this as equation A and call this one as equation B, let's say, or sorry, it is called as equation 1 Roman and equation 2. So okay, means I can just replace these equations by coefficients. We get these 2 equations, K1 W1 minus K2 W2 is equal to W3. Above equation just replace again coefficients, it is K1 W4 minus K2 W5 is equal to W6. Just we replace these 2 equations, if you understand. I just replace these terms by constants we taken. Here it is. So it is K1 W1 minus K2 W2 is equal to W3, equation number 1. K1 W4 minus K2 W5 is equal to W6, equation number 2. Now we will solve these 2 simultaneous equations. You know how it is. If I want to find out K2, I will try to replace K1, and when I try to find K1, I will replace K2. So let's say to obtain value of K2, I will try to cancel this term of K1, and hence to find out K2, so to find, let's say K2 first, what we can write, I will write equation 1, just I need to cancel this K1. So I can write equation 1 into W4, and if I subtract this from this equation, that means 1 into W4 minus, I multiply this equation by W4 and I multiply this equation by W1. If I subtract it, this get cancelled. So 1 into W4 minus 2 into I have to multiply by here W1. 2 into W1. And it gives, if I do this, what it gives me? It gives, yes, so this K1 multiply this equation number 1 by W4. So K1 W1 W4 minus K2 W2 W4, yes, minus this. So it is now minus what? 2 into W1. Let's say we'll write right hand side to the next side. This is just left hand side here now. So K1 W1 W4 minus K2 W2 W4 minus this. So it is minus K1 into W4 as it is into W1. So K1 W1 W4, this minus minus become plus. So it is K2 multiplied by W1, K2 W1 W5, and on the right hand side this W3 multiplied by W4, W3 W4 minus multiplied by W1. So W1 W6. Okay, next. So let's try to simplify. What we cancel, what you get here, this get cancelled as plus minus term. So by simplifying this, we can check what we can take common here. If I take K2 common from this side, our equation is K2 is equal to, just you can simplify and we observe here, it is W3 into W4. So 3 4 minus this 1 6, this term, divided by, when you take common this K2, it will be W2 W4 and W1 W5. So it will be, as it is on that side, it is W1 W5 minus this, minus W2 W4. It is value of K2. You know, to solve the equations, to get dimensional synthesis, that is to get link lengths, we need to find out K1, K2, K3. So I find out first K2 by using kinematic coefficients, W1 to W6. I know K2. Similarly, now see, to find out K1, to find out K2, I try to cancel K1. I cancel K1. Similarly, when I try to find out K1, I have to cancel K2. So similar procedure I will do. I will cancel K2 from these two equations, solving these two equations, and get value of K1. Equation for K1 I want. So for K1, what I do here, you can check. Similar procedure I will do. We know these two equations. So to find K1, what we can write is, so see, to find out K1 I have to cancel this K2. So multiply this equation by W5 and second equation by W2 and subtract from first. So I am writing here, let's say to find K1, I can do equation 2 multiplied by W5 minus, yes, sorry, equation 1 multiplied by W5 minus equation 2 multiplied by W2. So this we have to do, and it gives me, you can check what it gives me. So multiply this above equation, first equation by W5 and second equation by W2 and subtract from first. So what I obtain is, just simple K1 W1 multiplied by W5. So K1 W1 W5 minus K2 W2 W5 minus the second equation multiplied by W2. So it is left hand side, of course, K1 W2 W4, this minus become plus, it will be K2 W2 W5, and on the right hand side it is W3 multiplied by W5, W6 multiplied by W2. So it is 3 into 5 minus 2 into 6 multiplied by W2. So 2 into 6. Okay, so what get cancel here? It is K2, this is plus, this will be minus, and hence we get K1 value. So K1 by simplification, what it is? this term as it is. That term is W3W5 minus W2W6 upon this common term. So if I take common, it will be W1W5 minus, yes it is, multiply by, here we are multiplying by W4, so it is W4, so it is W2 W4. So this is equation for K1. So by equation from 1 and 2 we obtain K2 value and K1 value just by simplification, just by solving the two simultaneous equation. We obtain value of K2 first, and now that is K2 first, and now we obtain K1. When K1 and K2 is known to you, we know basic Fodase equation. We have three equations for three positions, that is this K1 cos phi 1 minus K2 cos theta 2. For each position we have three equations. So if we know K1 value, if we know K2 value, then we can put in any one of this equation to get value of K3. So to find K3, when K1 and K2 is known to you, to find K3, putting K1 and K2 in equation either of A or B or C, we can write either A, B or C, any one equation, we get value of K3. So K3 is equal to, if I put in any particular equation, so we will not write 1, 2, 3, but we will write it is K2 cos of, let's say instead of theta 1, theta 2, theta, I call theta I, K2 cos theta I minus K1 cos of phi of I plus cos of theta I minus phi I. So if I put that value of K1 and K2 in any one equation, you obtain value of K3 from this equation. So I know K3 also now, and we know that once you know K1, K2, K3, of course where I is, what is I here? I is varying from 1, 2, 3, as three positions we discuss. So when K1, K2, K3 are known, when K1, K2, K3 are known, then we know that K1 is equal to L1 upon L2, K2 is equal to L1 upon L4, K3 is equal to, you know equation, that is L1 square plus L2 square plus L4 square minus L3 square upon twice L2 L4. So by using these three equations we can find out, of course one length is known to you. When one of the length is known to you, we can design a 4-bar mechanism, means we can find out other link lengths. So when from above equations we can synthesize, or you can say we can design lengths of 4-bar mechanism, lengths of links, of course links of 4-bar only. From above equation we can design length of links. So this is your procedure for a dimensional synthesis of 4-bar mechanism by using kinematic coefficients. Briefly I just revise it. We know that we have to see how to solve a dimensional synthesis problem by using kinematic coefficients, and for this what is known to you, we have three angles, that is input angles, and three output angles are known to you, theta 1, theta 2, theta 3, phi 1, phi 2, phi 3. Correspondingly we can write these three equations, that is Fodase equation. But now as we have to solve this by kinematic coefficients for three accuracy points, yes, for 3 accuracy points. By using kinematic coefficients, we are not going to solve these 3 equations directly, but first step, remember first step we will do equation A minus B, we get this equation, we will do equation A minus B, after A minus B we will do A minus C, and from these two equations we get kinematic coefficients. Coefficients of K1, K2 and the right hand side are nothing but W1 to W3, W4 to W6. Once I get these 4 constants, 6 constants, then I write these two equations that obtained by A minus B and A minus C in this form. So what their form is? This one. So we written in terms of kinematic coefficients. So these are the equations in terms of kinematic coefficients. K1 W1 minus K2 W2 is equal to W3 and K1 W4 minus K2 W5 is equal to W6. Now solve these equations to obtain K1 and K2. So solving equation number 1 and 2, we get K2, then we get K1. How we solve? Already we discussed. We get K1, K2. Once we know K1, K2, to obtain K3, we will put value of K1 and K2 in any one of the equation A, B, C to obtain value of K3 for any position. That's why I written I here, where I varies from 1 to 3. 3 accuracy points we discuss. And if we know K1, K2, K3, then we know these 3 equations in terms of lengths. And if any one length is known, then we will obtain value of remaining lengths. So this is your procedure for a dimensional synthesis by using analytical method. Whenever that is analytical method of dimensional synthesis using kinematic coefficients and for a 3 accuracy points. So we discuss procedure. In next we will see numerical on this topic.